Welcome everybody to the .NET user group here in Tulsa. We are excited to have Nir Mashkowski with Microsoft talking about cloud native development, the cloud native development patterns on Azure Serverless, and awesome stuff coming up here. So I'm excited about this. Because I've been doing some serverless for a little while, I know that they keep saying there's always a server behind the scenes, but I absolutely love the fact that I don't have to worry about managing that server. I don't have to worry about how many servers are behind the scenes. I just get to, work on consumption and getting my apps out the door. So Nir, thank you so much for being here. I'm going to hand this over to you and let you take it away.
Yeah, I guess good evening, everyone. Thanks for having me. My name is Nir. I'm the Director of Product Management for Azure App Service, Azure Functions, Azure Container Apps, and Static Web Apps, and Dapper. And if you use any of my products, thank you. I'm still excited by people using stuff I helped create. I was the first product person on App Service. We just celebrated 10 years. Not just, it was June last year. So I guess we're almost at 11 years since we launched App Service. And I was there as the first product manager and later on as the team leader. I was also like Sean mentioned, I was the PM who gave the pitch to Satya to build Azure Functions back in 2016. And that's when we launched Azure Functions in preview and GA the same year. In 2018, I sort of took a long sabbatical and went and worked for AWS for 3 years. And over in AWS, I worked on the Redis implementation, Elastic Cache, and then I had the fortune also to work on Lambda, which is the AWS serverless product, and I got to work there for a year. And then I came back to Microsoft about a year ago, essentially to my old job. So I'm a very lucky individual that I get to have a second chance to come back home. So again, thanks for having me. My talk today is essentially the talk I give customers these days when we talk about cloud native development. And the cloud native moniker is something some people hold very dearly to. So I called it cloud development because some people are very strict about that, and they say, okay, cloud native is only Kubernetes. So I try to kind of capture how I see our customers use our tool set. And obviously I have 60 slides. We're not going to get through those, but I'll try to get us to the serverless portfolio, which is container apps and Azure Functions. So when I was trying to articulate cloud native, I thought it was sort of 3 areas, right? So one is platform, right? We have to have something to run on. The other one is process, because one of the changes that we see in this cloud era is that we can deploy more code faster and get feedback faster from our customers than we used to be able to do when we all compiled executable and threw them on some CD. And I still remember doing that, right? So process is very important. And then patterns, which is what type of applications are we building on this environment where we can leverage so much more scale and compute and global reach. So we'll start with the platform piece, and hopefully everyone has seen this one before. It's kind of a Gartner thing, but to me it really helped to explain the sort of the continuum of compute that's available in the cloud, right? So when we started, we all did lift and shift into VMs. It was trying to duplicate or emulate infrastructure we had in our own data centers. As you sort of move a little bit to the right, you have container orchestrators. Obviously, there's no more orchestrator war, and Kubernetes is the container orchestrator. where you have abstraction from your physical layer or VM layer, but you still have to work with a bunch of concepts around how Kubernetes describes a distributed application. And then we have PaaS serverless, where you give up more control over your environment for us to give you an opinionated way to create your applications as fast as possible. And obviously, after that, you have all the low-code stuff like Power Apps in the Microsoft case, and obviously all the other vendors have a similar product, although I would say that Power Apps is way ahead of everyone on that one. So I think that the other thing is, unless you've been living under a rock, Kubernetes is essentially the cloud platform. It's by now, to me, it feels like Linux. It's some open source with a bunch of commercial branches or folks that allows you to build cloud applications and model them in a certain way. It's super extensible. It's very elegant in how it's built, but it does bring a cognitive load with it as you want to start learning how to use it. Azure offers AKS, which is a great hosted Kubernetes. It takes care of all of the chores around managing your infrastructure, managing your VMs. It will make sure if your VM or node blows up, it will give you a new one. It manages the control plane, the etcd, and the API servers to make sure that they're still up. And it gives you a bunch of tools to an extension model to install and configure pieces of Kubernetes. And I'll come to that, come back to that in a moment. So that's sort of the platform, and I kept it quick just to save time. But essentially, the way I look at it is we have our proprietary stuff in Azure, which is our VMs and App Service and functions, and then we have our cloud native open source stack, which starts with AKS and continues on to Azure Container Apps, which I'll talk about in a few minutes. So the other kind of pattern for cloud development is process, and it's really about creating a continuous cycle of improvement, if you will. So when you look at applications that we have on-prems, or we help our customers move to the cloud, we typically see we saw lift and shift to virtual machines as sort of the first wave. Now, as a person who works on App Service, we do a lot of business moving ASP.NET applications or sort of monolith web apps or web APIs to App Service, because it's sort of close enough to what you run on-prem to where you can make some changes, but it mostly works well. And then we can see people starting to use containers, and in some cases, once they have a database and so on, use low code to do their business applications. So essentially, what we see, and I'll talk about that in the pattern piece, is people build microservices, which is a way to separate the concerns around different application domains, and they use APIs as a way to express them, and functions as a ways to implement them, or containers. And then they use the DevOps pieces to tie it all together into a continuous deployment process. So with this slide, I've been using this slide for many years, actually, but the concept remains the same, right? So we enable people to write their code with whatever local environment they want to have, Visual Studio, Visual Studio Code. Today we can use GitHub and GitHub Actions to, do our source control, build our code. We can use Azure DevOps or GitHub Actions to do some test pre-production. And then we have a lot of targets for deployment, app service functions, container app Kubernetes. Being at Microsoft, being a part of the developer division, we invest a lot of time and energy to make sure that we have wide coverage for these tools. And then we understand that you need to be able to monitor how users use your software and how your software behaves in the wild. And we create this virtuous cycle of you ship something out, you can put it in some kind of testing environment, you do traffic splitting, you make sure it works. If it doesn't, you go back, you rebuild it and send it out to production. And we're also taking part of that. So if you look at the products I work on, we have App Service, which is now a platform that's used by a bunch of internal Microsoft tools. There's pieces of App Service that still take a few months to release, but a bunch of the newer stuff has been broken out into microservices. So a service like Azure Container Apps essentially releases once a week or even faster. So we are sort of benefiting from the same technology changes. And one of the things I'm always excited about when I talk about the cloud and tooling is that we're sort of democratizing these very sophisticated and expensive processes. So you don't have to be Microsoft or Google or Facebook to be able to do continuous integration and deploy to the cloud all the time. All you have to do is sign up for a free tier of Azure Functions or App Service, and you get a bunch of these very expensive capabilities. So I'm going to go through some of the tooling, some of the new stuff that we have that helps kind of build this continuous integration cycle. So one of them is Azure DevOps. Azure DevOps is, for those of us who were as old as I am, started as TFS. It exists as an on-prem product and as a hosted product. It's very much alive and vibrant. There's a lot of investment, and what we learned is that even though GitHub is great, there's still areas where people want to have their on-prem installation to make sure their data is secure. And there's also a lot of investment in the DevOps programming model and APIs, and people like to use it. And if anything has changed for the better at Microsoft in the last few years, is that we really take the time to listen to customers and make sure that we build for them and not for some kind of a nebulous vision, if you will. So with Azure DevOps, you can essentially do your whole thing. We use it internally for planning for our own projects. You can use it for source control, and then obviously to automate your delivery pipeline. And again, we take care to make sure that all of our Azure compute platforms are well integrated with DevOps pipelines, and you can use those to deploy your code. The other push that has started, I guess, with Codespaces a few years ago, but continues to now, is to make the development experience simpler. So again, we all remember the good old days where you had to set up a dev machine and it took 3 days and you have all your tools, and then you compile something and it works, but it only works on your machine because you have VS and everything installed. So then you go to production, you're like, oh, what the hell, I'll just install Visual Studio on my production service because I know that it works, and you never figure out which DLL you missed. So those are days that are mostly behind us. And part of that is that with the cloud technologies, we can now replicate development environments and production environments to the cloud. And we have the magic of containers that can essentially package a whole operating system with all of the dependencies in one neat place. So if it works on your machine, it might actually work in the cloud, which is always a good thing, because then you don't have to stay up all night dealing with live site events. So GitHub Codespaces is essentially a hosted cloud environment where you can run your code. I'm actually going to show it real quick as in my demo. The other tool that has been out recently is DevBox. DevBox is sort of the enterprisey side of the Codespaces. It allows admins in large development teams to configure essentially a remote desktop that is a DevBox that has a lot of dependencies. And then if you have some, especially if you have a lot of turnaround and short projects, instead of wasting the first week of people onboarding, you just give them a DevBox and they have all the tools and they're up and running. So that's a tool that's available. I believe it's still in preview. But there's definitely a lot of interest and a lot of investment in developer division for that. The next logical step from that piece is deployment environments. I just pulled one slide out of a big deck, and if folks are interested in that, we can follow up with the deployment environments team. But the idea there is to say, I'm a large team. I don't need all my developers to become Azure experts. I don't need all my developers going into the portal and deleting production databases. So I can configure the capabilities through this admin interface, through this dev portal, and then I can make sure that they deploy where I want them to deploy. So I think it's a very powerful functionality. It's part of this sort of platform engineering team where, again, we built this super powerful cloud, but we're also giving a lot of people ways to shoot themselves in the foot, if you will. So that's development environments. And finally, once you sort of do your deployment, Azure Monitor is sort of the umbrella brand now for all of our telemetry and processing tools, where we collect all the data and show a bunch of insights on the data we collected. It's sort of a combination of a lot of existing brands like Azure Insights and so on, App Insights. And obviously, we also make sure that there's support for industry standard tools like your New Relic or Sumo Logic or App Dynamics and what have you. And we're also investing in open telemetry as a format to make sure that we can support things across the board. So I think we talked about it. Are there any questions so far? Or I can keep going.
No questions yet.
All right. So I'll take.
I'm sure there will be
It's
some
only water,
really good
I
ones
promise.
coming up, though.
You were saying?
I'm sure there's going to be some really good questions coming up, certainly on a lot of the implementation details and how they can get their hands on it. So,
yeah, that's fair. So let's talk about patterns. That's sort of the main. So this is sort of. So far we talked about how we build stuff, right? Where we built it is on the platform, how we build it with all these tools, and then let's talk about a bit what we build, right? So when I think about cloud development, with the benefit of sort of the looking back at the last 12 years, you know, we see these 4 areas, right? So you have your web applications, where, you know, everyone has something. They're customer facing. They're sometimes facing their line of business applications, and obviously the kind of corporate presence thing. And then specifically with our App Service tool, we see a lot of people using the web apps product to create APIs, because, you know, if you're running on port 80, you can return HTML or you can return JSON, and it's sort of the same coding to an extent. We see the APIs and integration, so people build APIs, then they want to weave them together and use them for connecting systems. So I don't know if we'll get to these slides, but we have the API management and logic apps and Beanstalk as our integration package for that. Then, in 2014, AWS came out with AWS Lambda, which is the notion of the event-driven applications where your code scales to zero and you only pay for what you consume, and more than that, you just submit code and you have sort of zero involvement with the infrastructure, and that's kind of the serverless vision that keeps evolving. And finally, what we've seen in the last few years is the cloud native or the microservice pattern, which narrowly defines microservices on top of Kubernetes as a cloud native pattern. And what it basically says, okay, if we used to build these applications and compile these big executables that had different libraries and different threads, if you will, we're going to separate those into different processes running on different containers. That will allow us to have less danger zone or blast radius when something goes wrong. It allows us to have many teams developing against the same application, and it allows us to use the right tool for the job, right? So if we need to process data, we'll use Python. If we need to use build a front end, we'll use JavaScript, and all of this will kind of speak together as one application. So that's the world we live in now, and yes, we sort of abstracted the complexity into small pieces, but that comes with its own complexity because now you need to monitor these things, you need to understand their interactions and so on. So I'll start talking about that, the pattern, the cloud native. And I mentioned previously Kubernetes. Kubernetes is the de facto standard to build these microservices. And it's all good, but this slide is the what I call the buffet of components that you get in CNCF. So to build a running application on Kubernetes, you need to set up a bunch of things. You need scalers, you need front ends, you need ingress, and you need to configure a bunch of things. You need your telemetry system, and then finally you can deploy your code. And the CNCF offers you a bunch of components you can use. The problem with that is that one, you have to figure out each of them, and it's also like taking a bunch of different medicine together, so they have unforeseen side effects when combined. What we try to do is, and again from the team that does App Service and Functions, what we try to do is to bring these things together and essentially build a recipe, if you will, to keep with the buffet analogy, build a recipe of things we know work together very well, and provide you with this platform as a service experience of productivity versus control that we bring you on the Azure platform with App Service and Function. So Azure Container Apps, we had a big release yesterday where we did a significant upgrade. And what it allows you to, we started off as a serverless container thing. Now we're offering both serverless and dedicated and high memory SKUs and so on, which allows you to really optimize your cost profile to what you need to do. Because one of the complaints about serverless functions is that they get super expensive at scale. So now you can have the same code running either on dedicated infrastructure or on serverless based on your cost profile and application workload. Everything is on open source, so it uses off-the-shelf Kubernetes, Kada, which is an open source CNCF product, Dapper, which I'll discuss a bit, Envoy, which is a router and front end that I think Lyft started. And there's one more sort of component called K4Apps that we develop at Microsoft that sort of makes it behaves like a platform as a service. And that one will be open source to a certain point. So what do you get with container apps? You can run your containers at scale. Now with our upgrade, we allow you to have dedicated VMs to run your containers, and we allow for hundreds of cores, and we can get up to a few hundred Kubernetes nodes under the hood. And if you need, again, to scale to zero, you can scale to zero. If you need dedicated, you can use dedicated. We help with the developer productivity. We have all of the things that are needed, like pre-baked GitHub Actions, the CLI, obviously the portal where you can set up your CI/CD. And obviously you can, if you have your own process, all you have to do is publish a container image to a registry, and we can consume it from there. There's also the notion inside container apps of revisions, and revision allows you to essentially control your workflow between testing, staging, and production. So every revision that you deploy doesn't go into production unless you set up a rule to say it goes to production immediately. If you put it in multi-revision mode, you can go and do traffic splitting between different revisions to make sure your stuff is working properly before you go to 100%. And then I think I mentioned the open source aspect of it. It's all a combination of open source components that we tailored to work well together. One is CADA. CADA is essentially an autoscaler. It takes a bunch of the smarts that we had in the Azure Functions product, where you can do scale to zero and react to different triggers. It does that in an open source on Kubernetes way, and it supports not only triggers from Azure, but also from AWS and GCP to make the applications more portable for the cloud native enthusiasts, if you will. And then it is an open source, but Microsoft contributes a lot to that, and we make sure it works on our stuff. Dapper is a capability that is that comes in together with container apps, and essentially the way I think about Dapper, it's kind of like a Win32 API for microservices. So it has all the pieces you need to take these disparate processes and make them an application. It has the service discovery, the ability for things to communicate with each other. It has the concept of bindings, where you can abstract your data sources and your outputs. And now we've announced a piece that does workflows, so you can create stateful workflows inside these distributed apps. So if folks who are familiar with durable functions and Azure Functions, we've made the same capability available on Dapper, which makes it available on ACA. Also, Dapper can be installed, again, directly on Kubernetes, and we have a lot of customers that are using Dapper essentially as their compatibility layer. So by using Dapper, they can run on vanilla Kubernetes, they can run on AKS, and then they can run on container apps. So what are we seeing people doing? Obviously microservices, event-driven processing is they run batches on container apps, they listen to queues and so on. We are working on support for jobs where you can schedule containers to run at certain times. So that's going to be announced soon. And obviously people use that a lot for APIs, because you can use the revision together with APIM to test different versions or provide support for backward compatibility on API versions. The other question I get a lot is, if I use container app, am I stuck? Can I move to Kubernetes later? And the answer is absolutely yes. We've already released a way to move from container apps to AKS using Arc as a bridge. So Arc is a hosted control plane that we allow people, if they want to run Kubernetes or AKS on-prem, but you can also do it in the cloud to move your stuff around, and we'll have more dedicated support coming up where we think about this container thing as a continuum, right? You can start in ACA, move to AKS, or you can start with AKS and then decide, so much to manage, let me move some pieces into ACA. A question so far, or I'll go to a quick demo? Guess everyone fell asleep.
No, not asleep. I know.
All right.
I know that we'll probably end up with some questions at the end, but doing good so far.
Cool. Okay. So folks can see my screen. To move this. Cool. So this is a simple application that's built on top of container apps. Of course, takes a bit of time to load. So again, essentially, very super simple microservice. It has some stuff on storage. There's an album API for song albums, and an application in React that shows the UX, and they talk to each other using Dapper. So Dapper is a sidecar. You just have to enable it for your application in container apps, and then it runs. And you can use it to abstract communication between your containers. You don't have to know the IP address and so on. And looking at the code, the thing I really like about it is that I can essentially go ahead and debug it in the cloud. So again, part of the bigger problem with the cloud is your code is running somewhere else. You don't know what the environment looks like. But with this, we can essentially have the same experience we would have with a client, but running the whole thing in Azure. So if I open this, run this application and try to load the UX, eventually it will stop in my breakpoint. It's just not being nice to us. It worked faster previously. There it is. So now we can see we can actually stop. We can do our normal debugging, see all of our variables and so on. And if I keep running, I'll get my list of albums. So that's a very simplistic capability, but again, I saved myself a bunch of time by having to set up all these things. I essentially just put it in GitHub and click the button that says enable code spaces or open a code space, and now I have a full-fledged developer environment. The other thing is just to sort of complete this CI/CD improvement we talked about is if I look at my portal, we created kind of a custom. If we talked about the Azure monitoring, we created a custom dashboard. I've been running some scripts to create traffic against this site today, and we can essentially see all the metrics that we're interested in, and we can create our own views and customize our dashboard. I guess I shouldn't have hit the refresh.
Happens every time. Every time you're
Yeah,
presenting,
of course.
everything just slows way down, doesn't it?
Yeah, it's part of the experience. So that's some of the metrics I was going to show on the other thing. And the other thing I think is really cool is the app map. So remember, I showed you the architecture in GitHub. And because I'm using Dapper, I'm getting this more visual representation of what's going on and the performance of my application. I'm sure. No, still rolling. That's cool. Okay, so basically what I try to show here is the continuous improvement cycle. Compared to what we had to do in the past to create these sophisticated application where we're getting all the tools to increase productivity.
So I have a quick question on Azure Functions.
Yeah.
I mentioned this to a friend of mine, and he's here in chat as well. So I want to make sure that what I told him is actually correct. And that is, with an Azure function, you are billed for the time that it's running, but not the time of any idle time after that. Actually, so I've got two questions. That's the first one. Is the startup and any idle time after execution, you're not paying for, you just pay for the actual execution time. Is that correct? Yeah.
So we have you just burst into the function section of this discussion. So thanks for the
the segue.
Segue, yeah. So we have the event-driven application with functions that allows you to again only pay for what you use. And Azure Functions is sort of a investment around that. It's important it has a unique sort of capability or design choice that makes it that has to be explained with a bit of nuance, which is it's actually an open source SDK, if you will, or a host. So if you look at serverless as a collection or as a definition, it has several things. One of them is this pay-per execution model. You can scale to 0 and then scale out when you get more events. And the other thing is that functions as a service programming model, where you just code your function and that's the artifact you deploy is a bit of code, and then we run it on your behalf, right? So with Azure, if you look at AWS Lambda, for example, AWS Lambda is built to run on AWS. There's no version on Kubernetes or version to run on-prem. We took a bit of a different approach and we said, okay, here's this Azure Functions open source product that can run essentially anywhere. So to answer your question, what it means is that you can use our consumption SKU that is fully hosted on Azure. And with our consumption SKU, you indeed pay per execution. But you can also decide that you want to run it together with your app service, for example, because you want to share the same file system. So in that case, you can deploy your function on your app hosting plan, for those of you who know the app service internals, right? You can also choose to run your Azure function on Kubernetes. There's a -- Kubernetes deployment option on top of in our CLI, where it will deploy your functions to Kubernetes inside a container and set up this SCADA thing as a scaler. So we offer more flexibility in the pricing plan. So it really depends on your profile, because I've done some back of the napkin, back of the envelope calculations, but essentially if you use a function for, let's say, a month against a VM, right? The ratio is 17%. If you use the function more than 17% of the time, it's cheaper to get a VM. Because by nature of those things being designed for short executions and all the infrastructure we have to hold in order to run it for you, it's more expensive. So there's a lot of cases where it will be cheaper and more robust to run them on dedicated infrastructure. And we provide that with our functions premium SKU, which is essentially managing real VMs for you running your functions. You still get the same programming model, but you have more selections on infrastructure. And indeed, once we shipped that premium SKU, AWS came out with a provision concurrency, which is essentially the same thing. They warm up a bunch of Lambda functions for you, so you can so you don't have to have a cold start. In terms of language support, we have all the major languages with SDKs that make it very easy to program against. The sort of stuff that we see people using is listening to events and streams of events, creating APIs quickly, because with an Azure Functions, you can just go in the portal or VS Code and you just write your HTTP method, and we take care of everything else. So you can publish it to the cloud or do it inside the portal, and you get an endpoint in a minute. And then more robust thing in terms of integrations, put it in as a step in a logic app, and then building pipelines for data transformation and so on. So we see a lot of usage. We also see a bunch of, today with the AI and data science push, there's a big growth in Python, where people use functions to sometimes train models or do inference, or convert or prepare data for training. So did that help the question?
Yeah, absolutely. I do have a follow-up question.
Yeah, of course.
When an Azure function is done with the call, the request, and my understanding is that the instance dies off. It does not wait around for another instance to come in. I believe a Lambda does, but I think a function, you get for every request coming to it, you get a brand new instance. So another one, an existing one, when it's done, it doesn't hang around and pick up the next request that happens to come in inside of an idle time.
Yeah, so it's a bit more nuanced than that. Okay. So I can speak with authority on what Lambda does. So what Lambda does is they launch an instance for every call. Now, what they do in order to optimize is you don't pay for it, but they keep these instances around for like a few minutes after the call is finished, in case another call comes in.
Right.
So that makes sense. What Functions does, Functions is not a single execution thing like Lambda. It's actually it's actually a web server. So it's multi-threaded. So what it does is the first call it will cold start, but if another call comes in the same time, it will actually accept it. So the profiles of scale out for Functions and Lambdas are a bit different. In terms of the cooldown period, it's the same sort of algorithm. It actually does stay alive and waits a little bit, and the amount of time it waits is dependent on capacity and some machine learning understanding of your behavior as a customer and so on. So it's definitely not black and white like you sort of articulated it. It's pretty smart in that sense.
Okay, yeah, I appreciate that. I've done a lot of work with AWS as well. Yeah. I even created a product that's on this marketplace, and I loved it because I was like, it's 100% serverless, and you wanted DynamoDB and several AWS Lambdas, and so I'm even familiar with the underlying system underneath AWS Lambdas. So I love that. But on the Azure Functions, something else that just came in that maybe you can speak to this and see if this is in the right path, but a function consumption plan versus a premium plan.
Yeah.
If you lift and shift a container to a function, you have to use a premium plan, which you have to pay for even during downtime. That's the statement. Is that, I want to challenge that, because I thought with even a container, you're not required to use premium.
So I think that it's there's difference between the behavior on the Windows flavor and Linux flavor. So for Windows consumption, it takes only code, not containers, because it's a Windows box. It doesn't have Docker. So that's why you have to go to the premium, because premium runs on a Linux boxes behind the scenes. You have the consumption Linux flavor where you can use a container. Now, what we've seen is that a very small percentage of our customers actually bring their own containers to functions, which validate the hypothesis that people would rather just let us deal with all of these pieces. But I can certainly follow up in depth if needed. In general, the difference between consumption and premium is that in consumption, you scale to 0, there's nothing there, and then we'll scale you out. Where in premium, you're guaranteed a minimum capacity that's always wrong.
Okay, so Robert, I hope that helps. And so I'm curious, Robert, if you're stuck with a Windows plan, or are you running that on Linux? So, all right, we'll follow up on that in just a bit.
Yeah.
Go ahead, Robert.
I was just going to say it's the container is delivered. It's a Linux container that's running a Java app. So because of the scaling issues, we were moving it into a function. And the infrastructure team wrestled with that for a couple of weeks, and they came back and says, well, you can't run this as a consumption. You have to run this in premium plan. And premium plan, it's like a flat, like a minimum is, I think it's like $700 a month is a minimum.
Yeah, it's not cheap.
Yeah. So yeah, we're still fighting, saying no. I think we can get this in the consumption based, because otherwise it's like, I don't know. So
yes, I think Sean has my email. You can ping me offline. I'll get you in touch with the team, with one of the engineers.
Cool.
All right. Thank you, Robert. Thank you, Nir.
Yeah, so there's something that's not announced yet, which in a few months will come out, which will help simplify a lot. But how do I say it? You can expect us to have a very similar pricing plan to Lambda coming up, where you can select your memory size and have larger machines, and it will scale out much nicer. So some of these gaps will not exist anymore.
So that's really cool that you mentioned that, and it's exciting that you're going to be in that competitive pricing like that. But I do want to clarify for the attendees here and to whoever listens to the recording, because this is kind of a misunderstanding on similar to AWS Lambdas. You get a free 1 million calls per month. So do you with Azure Functions. However, this is a little gotcha that I'd like people to know, is that it applies to every Azure function that you have and collectively into the Azure subscription level. Cool. That is where it'll add up, and you can hit 1 million calls rather quickly. So it sounds like you're going to have free calls for months. Well, you could actually outrun that in production within a couple of days. So just be aware of that.
Isn't that on the subscription level in Lambda as well, as far as I remember? I don't know. I have to go back and check.
Yeah. Okay. But yeah, I know some people had that misunderstanding. Sorry, go ahead.
No, the model for Lambda and functions is different because we have the notion of function app. And the idea was to enable functions to talk to each other because they're literally on the same box. while the lambdas are always on a dedicated micro VM. So it has some unintended consequences because one function out of function hub can hog all the CPU and then the other ones don't run. So it was kind of a good intention that needs some more tweaking. So again, you'll see us creating more knobs that will allow people to optimize those types of behaviors.
Yeah, all right. That sounds awesome.
So how are we doing on time? I think it's been an hour. We're having fun.
Oh yeah, keep going. This is good stuff.
Yeah, I think I have a meeting. Let me see it here. I think I have a meeting in half an hour, so I'll give it another. I'll finish with that demo and answer questions. Yeah. Cool. So I wanted to show a functions demo real quick, and that would be my browser again. So that's I have a function up, and as you've seen before, the architecture here. I'll put it back. I signed up to the New York Times API. I'll download. They have an API for top articles. I'm putting those URLs on a queue. And then there's another function that picks them up and downloads the actual HTML, strips the text out, and then sends it on as files in blob storage. As soon as the files appear in blob storage, event fires, and another functions loads that goes to, because you have to have AI now in everything, right? It goes to our cognitive services and summarizes the article. I haven't had time to build UX on top of it, but you can imagine that you can, put a URL somewhere and it gives you a summary of it. So we can see the functions, and those functions were developed in VS Code, and they're compiled as .NET Core, so they're in binary format. So we have the articles functions, and I can code and test it, get the URL. And I get all of the, some monitoring. And if we call this URL, we see the list of those top articles. Now I can go to my Azure Storage Explorer, and this is where we can start seeing those articles showing up as files. So you can see some kind of article. So again, that took a few hours to put together, but it shows the flexibility in how you sort of put things together with functions. So I think with that, I still have plenty of slides, but I think we can open it up for conversation, and I can answer anything else folks are interested in. I'll stop sharing now, I guess.
Okay, yeah. If there's any other questions or that you'd like to ask, you're more than welcome to come off mute or post it in the chat, and I'll ask for you, however you'd like to do it.
Oh, I can see the chat now that I'm not presenting. So.
I just wanted to clarify that you said that if we used a function over 17%,
yep,
that we're better off with dedicated resources.
Correct. So if you take the cost of a VM, I did it for Lambda and Azure Functions, and they each land around the 17%. It's a very primitive calculation. You take the cost of a VM in IaaS and the cost of a function, and you assume you run the function for the same amount of hours in a month. The 17% number is when you hit the VM price.
Okay.
And that's part of the, I know that we talked about the premium cost $700, but it's not that hard to consume $700 in consumption. So When I worked for AWS Lambda, I had the dubious honor of being the PM in charge of refunds. And I had the customers all the time that had an infinite loop and ended up with like huge bills because serverless is really expensive at scale.
So to challenge that though, I mean, VMs are great, but then it's something you have to manage. So if an Azure function is not going to be what I want, and I have to go to something cheaper, what an Azure App Service, which is 24/7, just as a VM is, maybe that's the next considerable option before getting to a VM.
Yeah, so the VM is just the price. I agree with you that there's so if you go and buy an app service box, it does have it does cost more than a VM, and depending on the model, it's different percentages. And the reason for that is because we set up the load balancer for you, we set up the storage. There's a bunch of costs you don't see, but is actually are in there, right? So you're right that it's probably more than 17% if you look at it in an app service machine. But that's why we offer function and app service, because we realize that we've seen a lot of customers complaining about a lot of customers just do the simple math. They say, okay, I'm going to run this for a month. Oh my God, right? It's $10,000 a month if I run function for a month. So then that's why we came up with the premium where or functions on app service that are also available, where customer can sort of optimize their cost structure. With the new version of ACA of container apps that came out yesterday, we make it even simpler because you don't need to even redeploy. You just say, okay, this app is now on serverless. Oh, it cost me too much. Great, I'll go to a drop-down box and make it dedicated. Another thing you can expect us to do in the next couple of months is start offering Azure Functions on ACA as a first-class citizen. So when you deploy a function, you can imagine you have a drop-down box that says, today you have consumption dedicated. You'll have also an option for a container app environment. And then what you get functions running on Kubernetes, and we set them up for you, and you get the same experience of management, and you also get this workload profile concept where you can move them from serverless to dedicated.
Oh, nice. And if I remember correctly, Azure Container Apps it's running on Kubernetes behind the scenes, but unlike AKS, you're still paying for the management plane. You just don't have access to it. With ACA, you don't have to pay for the management plane at all.
That's correct. We actually just eat that cost. We pay AKS, but we eat that cost in a different way.
Okay.
Yeah. So the core difference is that AKS runs on your subscription, right? ACA runs on our subscription, and we take responsibility for keeping it running on your behalf, right? Okay. And that's why there's going to be an export that takes it from our subscriptions to yours.
Nice. Okay. So, I mean, that provides some additional opportunities there instead of just just jump into VMs. But and I know like somebody was mentioning that, and they're running on AKS right now, and which AKS is great, and it also solves it's there and it's helped solve some big problems, but it does require people to understand Kubernetes and help manage it, and understand your pods and things like that. With ACA, that help a lot of that's, correct me if I'm wrong, but it seems like a lot of that overhead is removed from you.
Correct. So with AKS, let's say you're going to use CADA or ETC or what have you. When there's a new version, you have to take care of it, right? You have to go install it and make sure that it works. Just like we do in App Service, ACA, we take care of that for you. So if there's if there's a new CADA, we're going to install it and make sure it works, right? And again, things that are in the, in the oven right now is to take it even further and say, okay, I'm running a container with Node.js, whatever, we're up to 18, I don't know. When there's a new version of Node.js, we will take care of that upgrade as well. So we'll give you the whole PaaS experience, but you're on a cloud native platform. So for folks that are worried about multi-cloud compatibility, they don't have to worry about that anymore. While we still keep the same stuff going in App Service. So App Service is still heavily invested in, and like I said, the App Service now is essentially used as a bunch of ACA is now built on App Service. So a lot of control planes, of course, even AKS uses App Service for APIs.
Oh, wow.
The App Service is not going anywhere because I sometimes hear this kind of rumbles around the fact that it's been around, but we're also going to invest in making the Linux version of App Service more modern, allowing for sidecars and Dapper and things of that nature.
Okay.
Customers, you're not end of life anywhere. You can use any of our platforms based on what's convenient for you and what you have background in, and we'll make sure they're compatible across that continuum.
Okay, awesome. All right, is there, this is the last chance for any other questions? Okay. Good deal.
Question,
All right.
Just a big thank you.
Oh, my pleasure. Always
Yeah,
good.
thank you, Bill, for mentioning that. Yeah, Nir, we definitely appreciate it. Appreciate you being here, and I guess thanks for coming back to Microsoft. But
good learning for me.
All right, I'll go ahead and stop the recording and hang on for just a second.